I want to do a problem on approximating a binomial probability using the normal distribution. And in this problem, it says the first compute the binomial probability using the formula. So we can use the calculator. Here's the information given. We have n equal 45, so number of trials. This is our probability of success on any given single trial, and this is the probability we're finding. What's the probability of exactly 26 successes out of 45 trials? So we're just going to go over here to the calculator and go in second function vars, which gives us our distributions, and get down to binomial PDF, so binomial probability density function, and we're going to hit enter, plug in this information, 45, comma, 0.5, comma, and 26. And that'll give us this value here. You'll see 0.0693. So roughly about a 7% chance of coming up with exactly 26 successes in 45 trials. Again, the 0.5 is given. That's the probability of coming up with a success on any given single trial. So let's go on to the next part here. Why can the normal distribution be approximated? And they give us this little formula here, n times p times q greater than or equal to 10. So let's just run through that. N, again, is 45. So we're getting the same information from up here. N times P. P is times 0.5. And then we're going to multiply that times Q, or 1 minus P, which is times 0.5. 1 minus 0.5 is going to give us 0.5 here. And we're going to see what that is. That's 11.25, so it is greater than or equal to 10. So then we're okay. And why we check that is if the binomial distribution is heavily skewed, then the normal is not going to approximate it very well. So let's clear this out and go to the last part. And it says approximate using the normal distribution. Now, to be able to do that, we need the mean and standard deviation of the binomial distribution. So the mean of a binomial distribution is equal to n times p. Okay, so let's go ahead to the calculator again. So we simply multiply 45 times 0.5. So 45 times 0.5, and this is going to give us 22.5. Okay. The standard deviation is the square root of n times p times q. So we can multiply. We're going to take the square root of 45 times 0.5 times 0.5, parentheses. Don't put all parentheses in here. You got to put it in like this. And then we're going to hit equals. So we get 3.354. And now we're going to use the normal distribution, which is the normal PDF. Enter. And let me clear this up first. So second distribution, we're going to use the normal, and we're going to put in 26, which is what we're looking for, comma the mean, 22.5, and standard deviation 3.354. And again, we're going to come up with here this 0.0. You'll see there's some different choices. 0.069 is what we want.